Fatty fish like salmon, sardines, and mackerel offer a powerful blend of vitamin D and omega-3 fatty acids, two nutrients that do more than just support general brain health. Together, they act as potent modulators of neuronal autophagy, the specialized cellular cleaning process that clears damaged proteins and dysfunctional mitochondria from brain cells. This ability to stimulate autophagy within neurons is crucial, especially given the brain's vulnerability to oxidative stress, metabolic waste accumulation, and the buildup of misfolded proteins such as beta amyloid and tau, hallmarks of cognitive decline and Alzheimer's disease. What makes this connection truly compelling is that these effects don't come from extreme interventions, but from deeply nourishing, natural foods long recognized for their health-promoting properties. Vitamin D, when consumed in biologically active forms like those found in fatty fish, influences autophagy through its interaction with the vitamin D receptor, VDR, in brain cells. Once bound, this receptor-ligand complex can upregulate a suite of genes that participate in cellular repair, inflammation resolution, and autophagy. Studies suggest that vitamin D not only promotes the expression of autophagy-related proteins such as LC3 and Beclin-1, but also enhances lysosomal function, the final stage of autophagy, where waste is degraded and removed. This is critical in the brain, where neurons are postmitotic and cannot divide to dilute damaged components. Autophagy becomes the brain's primary maintenance system, and vitamin D serves as a key signal to keep that system active and efficient, especially during aging. Simultaneously, the omega-3 fatty acids found abundantly in fatty fish, primarily EPA and DHA, amplify these effects through their anti-inflammatory and neuroprotective properties. DHA, in particular, integrates into neuronal membranes, improving their fluidity and function, while also activating autophagy through signaling pathways like AMPK and SIRT1. These are the same longevity-linked pathways engaged during fasting and caloric restriction, suggesting that omega-3 rich fish can mimic some of the brain-cleaning effects of these more rigorous interventions. The activation of these pathways helps neurons detect and remove dysfunctional mitochondria via mitophagy, protecting them from oxidative overload and preserving cognitive capacity. In neurodegenerative conditions such as Alzheimer's, impaired autophagy is one of the earliest and most damaging disruptions. The failure to clear protein aggregates leads to cellular toxicity and inflammation, gradually destroying memory and executive function. The regular intake of fatty fish not only replenishes the brain's structural lipids, but also keeps its cleanup mechanisms functional. This dual action, providing both the materials to rebuild and the signals to remove what's broken, makes fatty fish uniquely suited to long-term brain preservation. Moreover, this influence is systemic. Omega-3s modulate inflammation throughout the body, reducing the kind of chronic low-grade inflammation that can travel across the blood-brain barrier and disrupt neuronal homeostasis. Vitamin D strengthens the immune response while maintaining tolerance, reducing the likelihood of autoimmune overactivation or microglial overreaction in the brain. Together, these nutrients build an environment in which neuronal autophagy can proceed steadily and efficiently, not as a crisis response, but as a routine function of a well-nourished, protected system. Importantly, the foods that deliver these benefits, wild-caught salmon, sardines, anchovies, and mackerel, are not exotic or experimental. They have long been dietary staples in traditional coastal cultures known for longevity and cognitive resilience. These populations have historically exhibited lower rates of dementia and better cognitive aging, even without the advanced interventions of modern medicine. Today, their dietary patterns are being validated by modern research as models for sustainable brain health. Incorporating fatty fish into the diet 2 to 3 times per week could act as a gentle, cumulative signal to the brain to renew, repair, and remain adaptable. This is particularly encouraging in a world where neurodegeneration is rising but where extreme measures, fasting, pharmaceuticals, or rigid protocols may not be practical for everyone. Instead, with each meal of omega-3 rich fish, the body receives a deeply nourishing push toward neurological clarity, resilience, and cellular housekeeping. Ultimately, fatty fish serve as both protector and cleaner of the brain. They don't simply slow decline. They help neurons function as if they were younger, more efficient, and more self-sufficient. In this way, vitamin D and omega-3s become agents not just of prevention, but of gentle, ongoing regeneration.